Hello, this is Jeremy Comel, Research Associate at Yale University and CEO of Innovative Omics. So today we're going to go over the scoring system of FluoroMatch. There is the Chabernet scale. There's also the Szymanski scale. The Chabernet scale is what the community has agreed upon for confidence in annotating PFAS molecules. So we will also in the reporting file over time have links to the Chabernet scale so that you can see those scores as well. And you can also see the scores from the Szymanski scale. So you can have different confidence criteria depending on which one you want to use. But we find for FluoroMatch, this scoring system was specifically designed for our visualizations and for filtering the data to validate and confirm molecules. And so this one is going to be the one we're going to cover in depth. So we do have, it's an A through E scoring system, with A being the most confident. A plus is something you will never see from the software. This is a placeholder for if you have confirmed targeted methods. So you have a standard, you know the retention time, the MSMS, the accurate mass. Maybe you even quantify the molecule, although that's not necessary, but you've confirmed it with a standard. So that's A plus. The A's are the most confident in the system that we have. So A is a molecule that has a rule-based MSMS annotation. That means that both it matched the accurate mass of the molecule and it has the required MSMS fragments. So for example, let's say you have a carboxylic acid, maybe it saw the loss of CO2 and the C2F5, and then it could be confident in that species structure along with the accurate mass. Now this false positive rate we've tested and validated against targeted methods, against chemical standards, against manually annotated sets, and in all cases we found a less than 5% false positive rate. And we published on this, and there's publication in the comment sections to see this validation. So highly confident species. If you have an A, that means it's within a homologous series with other PFAS chemicals. An A minus is on its own, so not in a homologous series. Either way, both very confident. You can be relatively confident in the structure. Of course, as you're reporting, you always still want to verify and manually look at all the evidence for some of these compounds in these series to confirm that the series is correct, which we'll go over in the following tutorial. Now, B's also have MSMS evidence, but this is tentative MSMS evidence. B pluses are using those same libraries as the A's, and these libraries, by the way, are over 10,000 PFAS chemical compounds developed from literature, from our own chemical standards acquired at Yale and University of Florida, and also working with the Environmental Protection Agency, where they've characterized all the major manufacturers in the US and some international manufacturers effluent, and added those MSMS rules to the libraries. And so quite a wide array of libraries to search against. Now the B pluses also search against those same manually curated nice libraries, but they don't have to have all the fragments required. So for example, if for a carboxylic acid we required a neutral loss of the CO2 and the C2F5, maybe only the C2F5 was observed. So these compounds often, I notice, are still correct. They're definitely the most confidence of the B's, but you will have to look through the fragmentation. Sometimes you get a B plus because your mass range is different than what the rules require. So maybe you have too high of a low mass range, so you miss some of the required fragments, or just different instruments with different collision energies. Sometimes the fragmentation is different than that was optimized for our rules. So it doesn't mean that your hit's not confident if you have a B plus, but you do definitely have to verify those compounds. Whereas the A's, most of the time, you can just accept that those are correct. Now, for the B plus, It's a 1 fragment from the class-based rule plus the accurate mass. A B, on the other hand, has an F fluorine-containing fragments and also is within a homologous series. So, for example, maybe has C2F5, C3F7 as a fragment, not necessarily have an accurate mass match to a library, not necessarily does it even have a name of a compound. So it could just be a feature without any name or accurate mass match, but does have some PFAS-specific fragments. So these Bs are likely PFAS. We don't necessarily know what their structures are, but again, some of the higher mass fluorine-containing fragments may actually be non-fluorinated fragments, and so they may not even be PFAS, these Bs. So it's important to look through that and determine if they're one of the low mass fragments, such as C2F5, CF3, CF3O, SF5, for example, that don't have any other formulas that could be predicted for those masses, and they're most likely PFAS. And we'll go through the visualizer to discuss that as well. The other thing is you want to make sure it's not a mixed spectra, so sometimes there's co-isolated ions that might fragment and give fluorine fragments, even though the feature of interest, the mass of interest, did not have any fluorine fragments. Now there's B minus, and that's pretty much the same thing as B, except for it doesn't have a homologous series. Some of those B minuses can be relatively confident, again, if they're one of those library hits, but all of these have to be validated. There also is, and it's not shown in these slides, a B minus minus, and that's something that has some kind of fluorine-containing fragment, but it's not one of the low mass, more confident fluorine-containing fragments. So it might not even be a PFAS. Now these C's are pretty helpful. These are the molecules, PFAS, that fall in series with B pluses or A pluses, but don't have any MSMS, or at least any MSMS matching data themselves. So maybe MSMS wasn't acquired, or they're too low in abundance to see any PFAS fragments, but they do fall in series with something that did have an MSMS-based identification or evidence. So C plus falls in line with the A's, C falls in line with the B's, and C minus can fall in line with the B's, but it only has 2 members of the series rather than 3. Now, what happens in the case of not falling in a series with MSMS and not having any MSMS evidence? And this is the D. So D plus, for example, is a series that has 3 or more. It has the right mass defect or an accurate mass match hit to a PFAS from the EPA CompTox database. And so these definitely can be PFAS. And if you look, again, we'll discuss the FluoroMatch visualizer in the next tutorial, but if you look at the retention time trends, they have a nice retention time trend. They have a nice homologous series. We can confidently say that they are likely PFAS, but we don't know anything about their structure. There may be formula predictions for them, things of that nature, but we have no MSMS evidence. D's have a homologous series, but they don't fall in the right mass defect or accurate mass hit. And D minuses might have the right mass defect or an accurate mass hit, but they don't fall into a homologous series. Usually we stop at D pluses. D's and D minuses will be very difficult to determine whether they're even likely PFAS. The other score that's not shown here is E, and E means it doesn't fall into any of the prior scores, which means it doesn't have the right mass defect, no accurate mass hits, no MSMS evidence, no homologous series, and in that case, we consider that likely not PFAS, which is very helpful because you can take out the E's and look at only those things that could potentially be PFAS. Now, just going back to the MSMS again, so this is the rule-based. We talked about those A's and B pluses, and could be a B minus that doesn't fall in a homologous series. So these are the rules from class-based standards where we get these rules, and this is the carboxylic acid. The actual rule we currently have in libraries is that you can either see the M- CO2 or the C2F5, and you must see the C3F7. So in this case, you can either see one of those two fragments, and you have to see the C3F7 to confirm the longer chain PFCAs. And so that's how our logic's set up. The libraries are set up so that you can change these rules. And then a tentative annotation, like we talked about for the other B's, or B plus rather than A, is that any of those fragments could be observed. And then we'd have a tentative annotation. Also, as you saw in the color schemes over here, so this will be helpful to look back and forth. These would be an in silico MSMS, so we took the SMILE structure, and based on that SMILE structure and our substructure fragment relationships, which we have 777 just for negative ion mode, and we have actually more even for positive ion mode with the substructures and the related fragments. And so taking the EPA COPTOX database again, looking at those substructures and predicting fragments based on that. And then, again, the tentative annotation can either be from that SMILE's predicted MSMS, where they get an MSMS from a SMILE structure, or from fragment screening, where there's no database, no predicted MSMS, and again, we're just finding any fragment in the MSMS spectrum. So here's an example of some scores. So on the top in the red, this is the A, and so this is a confidence score that has a homologous series. This is A- standing alone but still confident. Here's a C+, so this lighter color meaning there's only accurate mass matching, but it does fall in a series, the dark blue, of A's. So this would be a C+. D- only falling in a series with 2. So not having a 3 or more in the series, but having the right mass defect within the right mass defect range. A D+, having 1, 2, 3 in the homologous series and falling in the right mass defect range. Usually what your data set's going to look like, so this is AFFF, for example, is you may have a few A's. So in this AFFF, we had 74 compounds annotated confidently. That's actually quite a bit. If you're using water or blood or some other trace sample or even other AFFF samples, often you even won't get 74 confident hits because your MSMS won't be high enough. You won't get MSMS for everything. So expect this A sliver to be very small. We have a very large database. There's just only so many confident PFAS that match the database we've often see. Then you're going to have a much larger potential B's and C's, and those can be assigned confidently, especially when they fall in homologous series with A's. Then you're going to have a large amount of D's. Some of these are not even PFAS. Many of these are PFAS. They're going to be very difficult to look through. You may not even decide to look for them for validation. Just depends on the project. And then you have E's in the case of AFFFs. This was a smaller portion. In the case of blood, water, this might be a much larger portion that's not PFAS. And so you can ignore right off the bat 40% of your compounds, for example, in this database. So with that, I look forward to showing you the visualizer in the next video tutorial. This is definitely the most exciting aspect, I believe, of the software. Very nice way to look through all of the evidence and be able to annotate your compounds.